Good morning, everyone. I'm Marco Canevarolo, and I want to show you this paper, Apple Grading According to External Quality Using Machine Vision. This is my outline. In the European standard, apples are graded into 4 categories according to the external quality. So we have the extra quality, category 1, category 2, and reject fruit. And we have also the necessity to classify apple automatically with electronic grader. This gives us the necessity to improve machine vision and models to have high accuracy during the classification. So this is my material. So we used 528 golden delicious apple and 642 Jonah Gold apple. And the method is divided into 5 parts. The first part is image acquisition. So we have 2 cameras with an inclination of 45 degrees inside a lighting tunnel. I want to show you the black line because it's like the lighting tunnel. And on the side of the conveyor, we have 2 light sources and 2 frame grabber. And outside we have DPC to process the data. After that, we have the color grading. So we need to separate, first of all, the ground and the blush using neural network. And we have also to classify in 4 classes, from green to yellow. And to do this, we use Fisher linear discriminant analysis. After that, we need to separate the calyx and the stem, because it's very difficult to see defect in this zone of the apple or in this zone of the apple. So we use the correlation recognition technique to cut this part of the image. After that, we have image segmentation. So we need to separate the apple in 4 gray levels. So first of all, we have the black, that is the background. After that, we have 2 gray levels for the ground. And only for Jonah Gold apple, we have another color that is dark gray. This picture shows you the image segmentation of golden delicious apple. And after this slide, I will call blob this gray part, so the defect zone of the apple. After that, we have to characterize the blob. So we have 18 parameters to characterize the blob. That means that every blob have 18 variables. They belong to geometrical parameter, color parameter, texture parameter, parameter related to calyx and stem end. And if we know all these 18 variables, if 2 blobs is one close to the other one, using k-mean clustering, we can classify the blob into the same cluster if they're close one to each other. And after that, we have 12 clusters for golden delicious and 16 for Jonah Gold apple. In the end, we use 2 kinds of grading to perform this model. So we use quadratic discriminant analysis and neural network, and we compare these 2 models. So this is the result. In the upper part, we speak about golden delicious. And as we can see, we have a good grading in the extra quality. This number means the percentage. So we have 96% of extra apple correctly graded for the extra apple. But we don't have so good result for the other class. But if we consider only 2 classes, we have the 95% of correctly graded apple. And below you can see the same result for the Jonah Gold apple. In this case, we consider only the quadratic discriminant analysis method. If we consider all the apple, the correct classification is 78% for the golden delicious in the quadratic discriminant analysis and the 72% for the Jonah Gold. And if we use neural network, we have the 79% for the golden delicious and the 70% for Jonah Gold. This means that these 2 models have similar characteristics. So we can use one on the other. We don't have very high difference between these two models. What about the error classification? As I said before, the defect around the calyx and the stem are not detected, so this is a problem. And the most important defect that is difficult to find is the recent bruise. We can see in the picture number 2 some kind of recent bruise. This is not so recent, so it's easy to see this kind of defect, but this that is less visible is difficult to see with this kind of system. So only the 40% is correctly graded. And in the picture number 3, we can see rosy apple aphid damage that is only 13% correct graded. This is very difficult to grade this kind of defect, for example, in the John Gold apple, because the color is very similar to the blush. And the other error is only the 15% of the total error and 4% of the total fruit. But this kind of error is permitted by the standard. The conclusion is that the percentages show that this system is sufficient to grade this variety of apple, and we can also implement this kind of model in industrial machine. What about the bruise? This kind of errors maybe can detect using a near camera, so maybe we can improve this method. But the important result, I think, is this one, because using k-mean clustering, we have a method faster than the method done before this one. Because before this method, we usually use an operator to grade manually the cluster. So using an operator, we take 2 or 3 days to start the model. Thank you very much for your attention.
Do you have any question?
Thank you for your presentation. From the apple, can we be able to determine the presence of a worm inside being an internal quality using K-class?
Not with this method, because this method is only for the external quality. That's why.
And sometimes you can find some flabbiness in the apple, like some part is softer and some part is harder. Is it also because I could not really identify it among the
I think if the soft part show also a difference inside the color, I think it's possible to see this kind of defect. But if it's only soft, it's not so easy. So maybe only a small percentage of that kind of apple can be divided, correctly graded.
Thank you.
Any other question?
Thank you for your presentation. Page 5, you say, okay, 5. Okay, you say, you use 2 lights for both.
Yeah.
I think some lights are good, but I think some lights are not so good. Because, what kind of light is best? I think LED is okay.
This paper didn't show us which kind of light they use, but I know that LED is possible to do in this kind of system.
Okay, thank you very much.
Sorry, what kind of light? Generally, or something like I think it's a halogen lamp, but they didn't mention in the paper.
Oh, okay.
I speak about lighting too, so I think it's a halogen lamp. I don't know.
So I have one question. For example, so you check with this luminance, how about reflection of light? Sometimes direction is a little bit for image, and we can get some effect due to generation.
Next, show us next one.
That's the
Next
slide.
slide. It's easy to see.
Yeah, yeah. Maybe also this part is not written on the paper, but maybe they use some kind of air filter
Maybe.
to reduce the aeration.
Okay, thank you.
I get something strange. This one is from top view, and I guess that from top, that the illumination from top, right?
But this picture is only to show, is only to explain which part is blush, which part is.
Fine. But this looks like the emit the light from top. But your figure was from side. That's true. Before this previous one, from side. So more better position.
This is the real condition of the system.
But that next page image is different.
Yeah, I know, but the picture is only to show.
Something strange. Also, you should show us who is the author, who are the authors of this paper and affiliation, plus hopefully a journal name. These papers, who are the authors?
Within this one, Lemon, Marine, and the Spain.
Then the affiliation to which country?
Belgium.
Belgium. And what kind of journal? Okay. You should show us the first page or last page in your page.
Okay, thank you.
Do you have any other question? Oh, okay, so do you have any question from Taiwan? Questions? Okay. Yeah, please.
I want to ask how fast is this method? How fast we know the art is good or bad? Thank you.
Sorry, but they don't mention about time consuming about this method.
Okay, no problem. Thank you.
Okay, so no more questions from Taiwan.
Thank you very much. Okay, thank you very much.